Welcome to this explainer. So today we're diving into some truly groundbreaking work by Chindima Gunasena. He's a researcher and sustainability practitioner with over 3 decades of real-world experience, and we're going to explore his core philosophy, how human curiosity is actually the ultimate engine for sustainable innovation. Listen, if you've ever felt like you just aren't the creative type, this explainer is going to completely change how you view your own brain. Before we jump in, here's our roadmap for today. We'll be looking at the myth of innate creativity, the 6 functional units, nature's library of solutions, a real innovation journey, and finally, stewardship for the future. Section 1. The myth of innate creativity. Okay, let's address a massive misconception right out of the gate. We so often think of creativity as this magical gift, right? Like a genetic lottery where you either have it or you don't. But the reality, as Gunasena points out, is totally different. Creativity is actually a highly structured, step-by-step process. It's grounded in observation, it's about asking the right questions, and most importantly, it's a learnable skill that you can actively practice and refine. To really prove this, we need to look at what he calls the brain-informed innovation framework. And don't worry, it's not just a dense academic theory. It's a highly practical, science-grounded pathway pulling from neuroscience and systems thinking to show exactly how ideas are born and executed. It basically gives you the blueprint for how to intentionally cultivate your curiosity to build real creativity and drive environmental stewardship. Section 2. The 6 functional units. Let's actually trace how your brain operates as a literal innovation engine. Everything kicks off at the sensor unit. This is where you observe and detect a problem or a gap. Think of a farmer standing in a field, noticing the early signs of a severe drought. That observation is the absolute starting point of innovation. If your sensor unit isn't tuned in, you completely miss the opportunity to even start creating a solution. Once you sense a problem, your brain cycles through some incredibly distinct cognitive units. First up, the memory unit recalls past knowledge. Then your idea unit sparks to life, generating possibilities and brainstorming. Next, the design unit takes those messy, abstract ideas and starts building practical prototypes. And finally, the control unit steps in to evaluate the risks, weigh the options, and refine the solution before you pull the trigger. It is a beautiful, systematic flow of information. But here is the absolute kicker, the overarching energy unit. Listen, you can have the most brilliant ideas and flawless designs, but without passion, persistence, and resilience powering the whole shebang, your motivation just drops. And what happens when the energy unit fades? The effort gets abandoned. The energy unit is what provides that vital, sustained push to take an idea all the way to real-world impact. Section 3. Nature's Library of Solutions. So the mental framework is solid, right? But if you want to see this engine operating flawlessly at a massive scale, just step outside. For a staggering 3.8 billion years, natural systems have been running this exact problem-solving framework to survive and adapt. Nature is, without a doubt, the world's oldest and most successful R&D lab. By simply observing how nature handles complex challenges, like structural strength or water storage, we get a literal masterclass in sustainable engineering. This is biomimicry in action, and it is honestly brilliant. Observing nature's designs gives us ready-made answers. For instance, Japanese engineers studied the aerodynamic shape of a kingfisher's beak to make high-speed trains quieter and faster. We've used the bumps on whale fins to design highly efficient wind turbine blades, and we've studied gecko feet to create incredibly strong, reusable adhesives. Nature has literally done the prototyping for us. This brings us to a quote from the source material that really hits the nail on the head. Nature is not only our home, it is our greatest teacher and partner in innovation. When we actively learn from natural systems, we generate solutions that aren't just clever, they're incredibly efficient, adaptable, and totally in harmony with the web of life. Section 4. A real innovation journey. Let's ground all this abstract theory in a high-stakes, real-world situation to see how it can literally save communities. We're looking at a massive agricultural challenge. Farmers facing severe droughts every 2 to 3 years. Wells were drying up, crop failures were becoming the norm. It was a devastating cycle that demanded a serious, systemic intervention. Think about a complex problem in your own community as we walk through how they solve this. Notice how perfectly the framework maps to reality. First, the sensor unit identifies the drought. Next, the memory unit pulls field data and discovers that rapid runoff, not just lack of rain, is the real root cause. Then the idea and design units get to work, engineering a physical groundwater buffering system, using a recharge shaft and a silt trap to store monsoon floodwaters underground. Finally, the action unit builds a pilot program to test the whole thing out. When all 6 functional units fire together and are powered by the community's energy unit, the results are staggering. A single idea scaled from a tiny village prototype to completely transforming entire regions. Environmentally, groundwater levels surged. Socially, community participation skyrocketed. Economically, crop yields stabilized. They took a region prone to disaster and built incredible long-term resilience. And as that groundwater case study proves, real innovation is a journey. It's not just a one-off event. It requires moving iteratively through continuous learning cycles. You observe, you learn, you improve, and you share. And every single step of that journey has to be continually fueled by the passion and perseverance of the energy unit. Section 5, Stewardship for the Future. Ultimately, innovation isn't just about creating flashy new gadgets or maximizing corporate profits. It's fundamentally about our survival, and it's about stewardship. Whether you're a student, an engineer, a policymaker drafting laws, or an entrepreneur, this brain-informed innovation framework is for you. It empowers all of us to apply structured thinking to make better, highly ethical decisions for future generations. And the really exciting part? This is just the foundation. The next volume in Gunasena's series, How Creative Minds Challenge the Challenge, builds right on these principles. It dives deep into how we can challenge conventional assumptions to redefine really complex problems, bringing in even more practical case studies from the field. We have covered a lot of ground today. We moved from the basic anatomy of an idea all the way to transforming entire landscapes. So armed with the knowledge that creativity is a learnable, structured engine and definitely not a mysterious genetic gift, the only question left for you is, what real-world challenge is your curiosity going to solve next? Keep observing, keep questioning, and let your brain's innovation engine get to work.